Okay, so how do I know if a point lies on a line? We just have to check, just have to substitute. So to check whether this point lies on this line, we substitute -2 into x, 7 into y, and on the left side is y equal to 7. On the right side is -2, so you write -3 times by -2 plus 1, which is equal to 7, like that. And then we see they are both equal to each other, so you write left hand side equal to right hand side, therefore -2, 7 lies on the line, like this. And you can also check the other equation, like -2, 7 on this equation, and we check on the left side is 2 times -2 plus 2 times 7, so -4 plus 14 is 10, whereas the right hand side is 1, therefore they are not equal, so we conclude it does not lie on the line. Lie on the line. Okay. After we do this, we're going to continue. There's the gradient. To draw a line, we have to know how to calculate gradient. Gradient is rise over run. And then the equation of the line is y equal to mx plus b, where m is the gradient of the line and b is the y-intercept. Okay, y-intercept. And then after this, how do we draw a line? We have to find the x and y-intercept. So to find the y-intercept, we substitute x equal to 0 into there, and you get, and because the x coordinate is always equal to 0 for the y-intercept, and then we substitute y equal to 0 to find the x-intercept because the y coordinate is always 0. Alright, so now we're going to draw some graphs. So most of these you learned last year, so we'll just revise very quickly how to draw this. So this one you need a grid paper, so you can tell what the gradient is, what the y-intercept is. -1 is the y-intercept, 2 is the gradient, and the gradient is rise over 1, 2 over 1. So therefore, I could work out 2 over 1, so I could work out the rise and the run. So that's your starting point, that's where you start. So you start from -1, and then use the gradient. So you're going to go 1 across, 2 up, like this. This is your rise, this is your run. So therefore, I get to this point here, and then do again 1 across, 2 up, get another point. So now you get 3 points. You draw a line passing through all 3 points. So let me use a line tool. So I change the color to blue. Okay, good. So let's do that. And then I have to adjust the gradient. Okay, something like this. And then once you drew the graph, what do you have to do? You have to put arrows on both ends. So put arrow, arrow. Right, that's your graph being drawn. Okay, any question? I do the same thing for the other one. You have to find the gradient and the y-intercept. So to find the gradient, what you need to do is you make y the subject. 3y equals to 6 minus 2x, and then divide both sides by 3, so you get 6 over 3 minus 2 over x over 3, like this. And then you can work out y equals to 2 minus 2x over 3. So therefore, I get the gradient of -2 over 3, that's your gradient. And your y-intercept is 2, the number without the x. So therefore, your graph will start from 2, that's your starting point. And in this case, because it's negative, the rise is, the run is 3, so you go across 3 steps, 1, 2, 3, but you go down 2 steps. And then we get another point. We get this point here, right? So 2 over 3 means, -2 over 3 means you go 3 across, 2 down, and you can do that again. 2 across, 2 across, 3 across, 2 down, and then put a cross here. And then once you get 3 crosses, use a ruler to draw a line, and you get let's draw this. something like this. I change the color to blue. Blue. Okay, and put arrows on both ends. Okay, like this. Alright, so the line is drawn. Alright, any question? Okay, after we do this, we can now draw other graphs. We're going to draw the graphs again, different graph, but using a different method. So that's using gradient and y-intercept. Another method is to find the x and y-intercept. That could be quicker. So how do we find the x and y-intercept? What we do is we're going to find the x-intercept, you put y equal to 0. And put 0 equal to 2x minus 6. 6 equal to 2x, therefore x is 3. That's your x-intercept. So x-intercept means on the x-axis you put x equal to 3. And then after that you find the y-intercept by putting x equal to 0. So put y equal to 2 times 0 minus 6, which is negative 6. So you get negative 6 in here. That's your negative 6. Once you get 2 points, you just draw the line using a line tool. Okay, let's draw the line using the line tool, like that. Like that, okay. And put arrows on both ends, like that. Done. Okay, so as you can see, this method could be faster than the other method using gradient intercept. You can just find the x and y intercept, and you can draw the line straight away. Okay? Right, good. Alright, try the next one. Find the x and y intercept. Okay? Have a try. If not, let's go through this again. Let's go through this. So we're going to let's go through. So press this, that. Okay, so to find the x-intercept, put y equal to 0. Negative 3x equal to 6. X is negative 2. So it can be very fast. So substitute, plot a point negative 2. And then the y-intercept is to substitute x equal to 0. Negative 3 times 0 minus 2y equal to 6. So y equal to negative 3. Get 2 points. And then just join the dots. And of course you will put arrows on both ends. Right, good. So as you can see, this method is much faster than the gradient intercept form, because you just have to find the x and y intercept. You don't have to make y the subject. You can just do it like that. Okay, good. So we drew these graphs. I think we've got one more page to go through. We've got some special graphs as well. Okay, we're going to go through. Alright, hopefully all done. Okay, on the next page, what are the graphs? Sketch these special lines. So what's y equal to 2 look like? If you draw a table of values, the y values is always 2, regardless of what x is. And if you plot these points, x equals 0, y is 2, you get 3 points. You actually get a horizontal line. Okay, so y equal to 2 is a horizontal line crossing the y-axis at 2, whereas x equal to negative 3, you will find it is a vertical line crossing the x-axis at negative 3. So they're pretty easy. Okay, so these lines has got 1 intercepts. Okay, good. So how about this one? We have y equal to negative half x. I'm going to show you how to do it in 2 methods. The first method is finding the x and y intercept. So let's do that. So x-intercept, you put y equal to 0. So you get y equal to negative half times 0, which is 0, which is over here. And then you find the y-intercept. When you put x equal to 0, actually, I did it wrong. That should be the other way around. That should be y-intercept. Yeah. Sorry about that. So that's the y-intercept when you put x is 0. And now I'll do the x-intercept, put y equal to 0. X, y equal to 0. So when you put y equal to 0, so you get 0 equal to negative half x. And then you times both sides by 2. But anything times by 0 is 0. So you get 0 equal to negative x, x equal to 0, which is also the same point. So both the x and y intercept are on the same point, isn't it? Whereas on the other example, it's separate point. You can draw a line. But when they are the same point, you can't use it to draw the line because the line can go anywhere. So what do we do when this happens? You just have to pick one extra point. So what you do is, let's pick another point. Let's pick x equal to 1. Can be x equal to 2 or negative 1. I'll just pick x equal to 1. Substitute, or maybe 2 better because you won't get a fraction. Then you get y equal to negative half times 2, negative 1. So you get the point 2 across, 1 down, this point. So you just need one extra point to draw a line. When you get 2 points, you join them together, you get the line. Arrows on both ends. Alright, so sometimes the x and y intercept method are not very useful when both the x and y intercept are on the same point. Now, this is the part where the gradient intercept form are better because you can see what the y-intercept is and you can see what the gradient is. So for this case, negative half x plus 0, the y-intercept is 0, which start from the origin, and the gradient is negative half, which means that it's going to be 1 over, so you're going to go 2 across, 1, 2, 1 down because the gradient is negative. Put across and do that again, 2 across, 1 down, you get another point. So once you get 3 points, you draw the line connecting these 3 points, you get the graph. So when you get y equal to a number times x, which in the form of y equal to mx, without the y-intercept, where the y-intercept is 0, it's better to use this method because because you can get the line more quickly. Okay, any questions? So you got horizontal line. Just remember when it's y equal to number, horizontal line, x equal to number, this line, y equal to mx, without the y-intercept, it's a line through the origin. And then you might like to use the x and y-intercept approach to draw the line, finding x-intercept and the y-intercept. And then you also need to know how to check a point is on the line. Okay? Alright, that's last lesson's work, so hopefully you can finish that by yourself. And today we're going to proceed to find the equation of the line. So we'll learn how to draw the graph. Now we need to know how to find the equation. Alright. Okay, good. So what we do is we're going to review some of the formulas that you've learned before. There is the gradient formula. The gradient formula states x y2 minus y1 over x2 minus x1. This is the gradient formula where we know the coordinates of 2 points. x1, y1, x2, y2. Like that. Okay. Which is really, this is just rise over run, isn't it? When you do the difference of the y over difference of x, it's the rise over run. And to find the equation, you need to know the gradient and the y-intercept, mx plus b, which you've learned before. Another formula you need to know is the point gradient form. So you're given a point and given a gradient. Then the equation of the line is this. Whereas on the other one, you are given the gradient and the y-intercept to get the equation. This one given a point, which doesn't have to be the y-intercept, and a gradient. Right, so what we're going to do is we're going to find the gradient connecting 2 points and then find the equation given a graph. Okay, so we'll do the first one. Determine the gradient of the line joining the pair of the points. So basically we're just using this formula here. Okay, we're using this formula. So we're going to try to do that. So what you do is you go name the first point x1, y1, the second point x2, y2. And using the formula m equal to y2 minus y1 over x2 minus x1, you can use it to calculate the gradient. So y2 minus y1 is negative 2 minus 8 over 5 minus negative 3. Like that. So y2 is negative 2, y1 is 8, and then x2 is 5 minus negative 3. And if you do the arithmetic, you get negative 10 over 8 which simplifies to be negative 5 over 4. All gradient needs to be simplified to the simplest form. Okay, after we calculate the gradient, we're going to find the equation of lines given the graph. So the graph is drawn for you, we need to find the equation. On the previous exercise, given the equation, we want to draw the graph. Given the equation, we draw the graph. This one, we'll given the graph, find the equation. Alright, so all you have to do is, when you find the equation, you must get the gradient. Once you get the gradient, the equation is easy to find. Let's find the gradient of the first line. To find the gradient, you need to do you can find the rise over run, or you can just use the formula m equal to y2 minus y1 over x2 minus x1. Both will work, but this one I'm going to calculate, so the difference is 7 because 8 minus 1 is 7, 4 minus 4, 0 is 4. So 7 over 4 is the gradient. So let's work out the equation. What's the y-intercept? B. Where does it cross on the y-axis? 1, right? 0, 1, that's the y-intercept. So using the formula y equal to mx plus b, I could now replace m and b by the values that we just found, which is this having found 7 over 4. So we write 7 over 4 with the y-intercept of 1. So we get y equal to 7 over 4x plus 1 is the equation. So it's very simple when the y-intercept is given. We'll do the case where the y-intercept is not given, which means that we have to use the other formula called the point gradient form. Okay, let's use that formula to find the equation of this line. But first we have to find the gradient first. So using the formula m equal to y2 minus y1 over x2 minus x1. So I'm going to call this x2, x1, y1. This is x2, y2. Okay. And using this formula, you do 7 minus 11 over 5 minus 3. So the answer will be negative 4 over 2, which is equal to negative 2. Okay, that's your gradient. As you know, that is going downward, it must be negative. When the line is going upward, the gradient is positive. Okay, now this time they don't give you the y-intercept. Like this one, we don't have the y-intercept. So we have to use this formula here. Okay? So to use this formula, we just have to pick a point. You can pick this point, for example. Or you can pick the other point. You get the same answer. Let's pick this point, 5, 7, because the numbers are smaller. It doesn't have 2-digit numbers. Okay, let's do that. So what we do is, let's write down the formula first. Y minus y1 equal to m, x minus x1. Okay? And the good thing is that we've already got the gradient, negative 2. And these points are exactly the point you just chosen, 5 and 7. So you do y minus 7, x minus 5. But the y here doesn't change, that's the y. This doesn't change, that's the x. Just the point y1 and xy has to be substituted. Okay, so what we do is, you just have to expand. Negative 2x plus 10. And then make y the subject, move the 7 over. So you get y equal to negative 2x plus 17 is your final answer. Okay, hopefully you get the idea. If not, just let me know. So that's the equation. The gradient formula, the gradient intercept form, if you know the y-intercept, or the point gradient form, which is used in example 3. So you are not given the y-intercept, you have to substitute the point to get the equation. Okay? Alright, good. So we did it in less than 20 minutes. That's good. Thank you for your